In part 3 of this subsection, we established that in this configuration, with our 100 pounds hanging from a point 3/4 of the way over across this bridge, that our left bridge support is lifting 25 pounds and our right bridge support is lifting 75 pounds. So let's look at the loads on these other members here. Okay, let's look at this point. We have 25 pounds lifting up from the bridge support. We have a zigzag here and a horizontal flange here. Well, the horizontal flange has no vertical component, so the zigzag, the vertical component of the zigzag, has to balance out this 25 pounds. So it's pushing down 25 pounds and consequently over 25 pounds because it's pushing that way 25 pounds times the square root of 2. So we could write 25 times the square root of 2, or we can just multiply it out. Let's see. 2 invert square root, there's square root of 2, times 25 equals 35 point, and then a long string of numbers, 35.35533906 I got. Let's just call it 35 pounds of compression. Abbreviate it. Okay, so this compression zigzag here is pushing 35 plus a little bit on this point at a 45-degree angle. And we could say it's pushing up 25 and it's pushing to the right 25 on this point. Well, we know this has no vertical component, so the vertical component of this zigzag balances out the vertical component of this zigzag, which is going to be 25 vertical. This one's pushing up, this has to pull down, so it's in tension, so it's going to be another 35 tension. No, it's vertical and it's horizontal, or 25, but the resultant vector is 25 times square root of 2, which makes it somewhere around 35. Okay, so looking at this point, we have this one pushing up 25 and right 25. We have this one pulling right 25 and down 25. The up and the down cancel out, but you still have 25 to the right from this one, 25 more to the right from this one, so this one has to be pushing 50 to the left. So it would be 50 pounds of compression. Okay, let's look at this point. It has this 35 resultant zigzag, which is 25 pulling up, 25 pulling to the left. Whoa, we skipped this one. Let's go back to this one. This 25 in compression, vertical, 25 in compression, horizontal, means this has to be 25 tension to balance out that 25 compression to the left caused by this zigzag. So 25 tension. Okay, now we can get back to this point. This zigzag is pulling up 25 and pulling to the left 25. This bottom flange is pulling to the left 25. This zigzag, its vertical component has to balance this one's vertical component. So if this one's pulling up 25, this one's pushing down 25. So its vertical component is 25, so its resultant component is 25 times square root of 2, so it is a 35 compression member. Okay, this zigzag is pulling this point to the left 25. This bottom flange is pulling this point to the left 25. This zigzag is pushing this point to the left 25. So 3 times 25 is what this one has to pull to the right to balance it all out. So the stress in this member is 75 tension. Okay, we go up here. there's no vertical component of that one or that one, so the vertical component of this one has to balance the vertical component of that one. And since this line is at the same angle as this line, 45 degrees from horizontal, it may not look that way. This is a 90-degree angle here. These are 45s. But anyway, this downward component of this equals the vertical component of this, except this one's pushing up, so this has to pull down. So the resultant is another 35 tension. And same deal here, 35 compression. Okay, well, at this point, let's see, we have 50 pounds pushing to the right from this top flange member. We have 25 pounds pushing to the right from this one. We have 25 pounds pulling to the right from this one. So that's 100 pounds. So this top flange has to push this point 100 pounds to the left. And it has to be a compression member before it can push. So that would be 100 compression. Okay, let's look at this point. We have 75 tension pulling it to the left, 35 tension resultant, but 25 horizontal to the left, so that's 75 plus 25 so far. There's another 25 to the left, so 125 pounds of tension is what we have here. And looking at this point, well, we have 100 pounds pushing it to the right from that top flange. We have 25 pounds pushing it to the right. Well, this zigzag has to balance the vertical component of it, balances the vertical of that. They're at the same angle, so this is another 35 tension. So we have 100 plus 25 plus another 25, that's 150. So this top flange here has to push to the left on that point, 150, so it's 150 pounds of compression. Okay, this 75-pound bridge support, it is being counterbalanced by the vertical component of this zigzag. So if the vertical component of this is 75, its horizontal is also 75, which means this horizontal member has to balance out that 75. So this would be 75 of 75 tension. Okay, this one is 75 times the square root of 2. Let's see what that is. 2 invert square root times 75 equals 106.06600172. Let's just call it 106. So that would be 106 pounds of compression. Okay, so this one is pushing up on this point 75 pounds, and it's pushing to the left 75 pounds on this point. This zigzag is pulling down 75 pounds on this point and pulling to the left 75. So the 75 down that this one is pulling balances out with the 75 up that this one is pushing, but they're both trying to push or pull this point. Each is trying to pull it 75 pounds to the left, which means this has to push 150 to the right. And just as we figured out coming from the other end, that's 150. So that's how the loads look on a truss when the weight is moved.